All right, welcome to another episode of Unstructured Unlocked. I'm your host, Tom Wild. And today we have a really fascinating guest, Andrew Carr, the founder and chief scientist of Cartwheel. And Cartwheel is a generative motion company. And we'll let Andrew tell us a lot more about that. But this is a really interesting episode where we'll dive into sort of the art of the possible, maybe taking a different view of unstructured data. Obviously, we've focused a lot on how to get intelligence and information from unstructured, but what if you take a look at it in the opposite direction? So Andrew, welcome to the show.
Thank you. I'm excited to be here.
Tell us a little bit about your background as it relates to, this blizzard of new technologies we're trying to interpret, whether it's generative AI or agent architectures and all of those kinds of things. And what's the kernel of the problem that you're working on at Cartwheel?
Certainly. So I am still somewhat new to the field. I started working in machine learning in 2016. And so it was pre-transformers, but only just.
Yeah.
My background is actually in applied mathematics. And so I spent a lot of time and effort studying high-dimensional geometries, probabilities over geometries, and so on, which I enjoyed thoroughly. And there was, three other people in the world who enjoyed what I was working on. And so I was sequestered away in my little kingdom of the world, but it turned out to be extremely applicable to machine learning, which I found very quickly when I was starting to search for things that I could do with this set of methods and technologies I was working on. I entered the field of machine learning working on medical imaging. I was trying to dramatically decrease the cost of MRIs. I worked on some audio technologies, and then really stepped into the field doing predictive physics at Lyft, where I briefly spent time on the prediction team trying to figure out how cars move with relation to other cars. Very specifically, I was working on, it's called the follow car, but can we predict the trajectory of the car right in front of us? Because at the time we were experiencing lots of harsh braking events, which is no fun. It's safe, certainly, but it's no fun.
Yeah.
And so loved that. During my time there, however, the reason it was brief is I quickly realized that self-driving would take significantly longer than I wanted it to take. And actually, I saw that it might be an AI complete problem with some, air quotes there, essentially meaning we actually have to solve intelligence maybe before we solve general purpose driving. And so I said, well, I might as well work on intelligence. So I went to Google Brain to work on some interesting problems there. And then I went to OpenAI as a fellow to work on program synthesis, so models that write code. And there really got exposed to what is called generative AI today. It was, there's lots of names for it. It's gone through many transformations, but that's where I got my feet wet. And while at OpenAI, I had this model that could write code. It was really good at writing code, specifically Python. And again, I was searching around, looking to where I could apply this in somewhat novel ways, right? We were building GitHub Copilot, ChatGPT was in development. There's like lots of places where this was very generally useful, but specifically, I was still looking.
And
there's a piece. Oh, go ahead.
One of the co-founders at OpenAI, right?
I did, yes. I worked with Alec at OpenAI, one of the singular most brilliant scientists that I've ever had the pleasure of working with, and unashamedly humble and doesn't seek the limelight. Anyways, a very impressive person. So yes, Alec is amazing.
Yeah, I agree.
And I also got to meet Madison through the program synthesis circles. He does some of that work as well. And so yeah, it was excellent time. So I was searching for a piece of software to put programs into, and there's one that's called Blender. And this is probably not familiar to much of the audience, but it's a 3D animation modeling software. It's free and open source, but essentially a professional artist could use this to animate a Pixar-like film or create some simulation with smoke for VFX and so on. Very powerful. And built into it is actually a Python interpreter. And so you can write Python code in Blender, and it will be executed by the simulation engine or the rendering engine or whatever, and do stuff in the 3D viewport. And so I thought, well, I don't know Blender, but I would like to use it. I have this thing that can write Python. Let me just try and hook it up. So I went through that process and was able to type in text. It would output code that would then get executed to do things in Blender that I myself could not do.
And these
But
are
the key,
primarily a three-dimensional engine. Is that
that's right. Yeah, so it's, there's lots of them. Game engines like Unity and Unreal,
Yep.
3D engines like Maya or Blender, right? But correct, like you can create a sphere and then you put cameras and lights and render it out to look like the Earth. And so that's how much of modern graphics is done in these 3D softwares. I think the light bulb moment for me here was after the model was finished running and I executed the code, I could go and edit anything I wanted to. I could move the objects, I could change the timing. And we get that for free in text. You can go in and edit text after it's generated all you want. But we don't get that for free in images and videos. And so artists are really limited by the ability to edit the output that comes from a model. So it's really exciting for me. And I said, this is so useful, I think, that I'm going to go start a company to do this. And so that's what Cartwheel is today. We've moved on from Blender. We've, built our own models, but fundamentally, you type text as input, you get motion, animation in 3D as output that you can edit. You can move the arm of your character, you can make them run faster, slower, you can change the character, change the colors. You do whatever you want in a way that is meaningful and useful for the end user to try and empower artists. And so that's really the story that's led us today. And we can talk more about Cartwheel in a bit, but editing motion, trying to accelerate creativity is like the core.
Yep. So this really resonates in that, if I were to generalize here, I always think there's sort of two main ways to start a business, right? You either have deep expertise and understanding of a business use case, right? Or you're going to innovate from the technology side. And they sort of meet in the middle because somehow you have to solve a problem that people will pay money for. Hence the business is, lifeblood long term in terms of becoming a self-sustaining entity. I also have quite a bit of familiarity starting businesses from the technology side and working towards, what's the right problem to solve from a business framing to turn it into a viable commercial enterprise. It sounds like that's what you're doing here too. So tell me if you could, the bit of the journey you've been on to go from what you just described, which is very powerful, but where's how will you find the problem space in the market that's really going to resonate? People call it the killer app, whatever you want to
Right.
call it, but the killer app, because you could do
That's
many
right.
things.
You could do many things with it. And fundamentally we're predicting motion over time and you can put that anywhere. And so where do you put it that's actually valuable?
Right.
So a few months after I left OpenAI, I was working in my basement trying to get this thing to actually do what I wanted. And I got an email from the OpenAI team and they said, "Hey, hope you're doing well. We tried to hire this guy to do product and design work for us. He pitched us the exact thing that you're working on. You should probably talk to him." And so that's my co-founder now, Jonathan, brilliant man. He
Excellent.
was an animator for a long time. He was motion design at Google. He led the rebrand. He did his own agency, his own startup. Anyway, brilliant. We don't have to get into it, but essentially he has deep, deep, deep product expertise for what animators want, what they like to build. And so I met him and we're off to the races. And so
Yeah,
in
good
some
example.
sense, yeah.
He is. So in this case, you've got a subject matter expert with this from the use case side meeting you on the technology side. So good formula.
Yeah, it's worked really well. And there's some standard answers. We talk to our users a lot to try and figure out what exactly they're building. We've identified gaming, I think, is a huge segment of people who care about the craft and care about the storytelling, but for a number of reasons care about speed as well. And so enabling them to move much faster and while maintaining quality, I think, is an appealing push for them. But it's early days. I mean, we just launched the tool in the last few months. I mean, it's just gotten to the point where it's usable. And so we're the very beginnings of that journey.
Do you feel like is the big so what here that you're able to turn illustrators and animators into programmers effectively? Is that the right way to say it, or how do you think about it?
We're able to actually turn, yeah, I think about it the other way. We're able to turn every person into an animator, is how I like to phrase it. So
Yeah,
I don't have the skills to animate, but I would love to tell stories. I would love to visualize what I'm thinking and create a really compelling narrative. If I tried to pay for that, it would cost me in the hundreds of thousands of dollars. If I were
yeah,
trying to do it, it would take me 2 or 3 years. So instead, I have Cartwheel, which hopefully allows me as an every person who might have a story, get that out onto the page. It also is useful to existing professionals who are currently animators, who want to take on more ambitious projects, who want to do more client work if they're a freelance artist. And so really we're trying to make everyone an animator to tell stories.
Yeah, that makes sense. Sometimes when I talk to people who, aren't from this side of the market, what's the big deal about generative AI? I think one of the ways I describe it is Gen AI is as much a new programming language as it is anything else. It programs with natural language and effectively, dramatically lowers the bar to who can be a programmer. Do you agree with that, or how would you tweak that?
I absolutely agree with that. It lowers, yeah. So I would say it raises the floor of what people can do.
Yep.
So every person now is much better, in theory, at writing code.
I like that. That's a good tweak, that raise the floor rather than lower the bar. Yeah, I like that.
Yeah. But it also does, sort of in the maintaining that theme, raise the ceiling for the existing set of programmers, right? And so everyone gets this shift upwards in quality, which has honestly been amazing to observe. Like I consider myself a pretty good programmer. I've been programming for a number of years on some really interesting projects. And I myself find hours saved every week by using some of the latest programming tools. And
Yep.
and then we have some junior folk on our team who have just joined, and they're saving weeks worth of time programming stuff that they maybe even couldn't have done. And so yeah, it's been very good for us to at least the coding aspect of these generative tools.
So the other piece that I wonder about is this idea of commoditization and defensibility in the
Mm.
age of large language models. How have you guys thought about the defensibility piece? And do you agree that, or disagree? Are large language models going to reach a point of commoditization, or do they go specialization with, small language models and things like that? How does that relate to, is that the right question to ask a company like Cartwheel?
Right. So there's a few questions here. If we tackle the cartwheel question first, we are fortunate to not be training a large language model, right? We're training a small motion model. I don't know. It's its own data type in the same way that images and video and text and audio are their own data types. Motion is actually this new thing. And so what that means is, at least for us, we've built everything top to bottom. We have our own hardware, we have our own training stack, we have our own models, we have our own data and everything. So we are fully vertically integrated, and it's hard to compete with that just because you can't, like GPT-4, amazing model, can't generate motion. Just doesn't, it's a mismatch in data type.
Yep.
So from that perspective, there is a little bit of defensibility around the technology, and it's not approachable by some of these general purpose tools.
Yep.
But I think if you zoom out a little bit, sort of the core of this question, if GPT-5 comes out, or GPT-6, or Claude 4, it doesn't matter, and it suddenly can do all sorts of new things, is it worth having built those new things in the first place, or just waiting, right, for this model to come along?
Right. Do they need to do those things in their ever expanding quest, to grow their market?
Right. It's hard to say. I think there's one piece of shining light that I see, which is tuning a model on your own data still to this day always beats out the frontier models on performance every time. And that hasn't changed. So you can train a really small model on your data and it's better. That has never not been true. Of course, I can't extrapolate, I don't know, but I would be very confident in saying that that will always probably be the case. Specializing a model for your use case is always good. So what does that mean? Well, you need data to train that model on. And that's your data. And for the insurance use case, which many of your audience care about, that's private and protected data, which requires a lot of expertise to access and manage and maintain and secure. That's, I think, where the value comes in, the stuff that people are already doing, but just maybe leveling up slightly to integrate with some of these new tooling.
Yeah, and I think we've definitely embraced that. I think that, going back to the founding of Indico, that was their hypothesis, right? The founders, several of which are still with us. Some have gone on to do interesting things like OpenAI. But the big intuition when the company was started was just what you said, that using deep learning and transfer learning, allow our customers to build custom machine learning models really fast. Those models end up being very, very small, but very, very performant because they're so precisely trained. And then being able to assemble those into, a series of steps, a workflow, almost to create like a digital twin of how the manual process is done today. And it's interesting, we just published a benchmark, an LLM benchmark. There's lots of LLM benchmarks. What we did to have a little bit of a different take on it is to focus specifically on the extractive use cases and somewhat the interpretive use cases. But extractive is still, discriminative is still far and away the best approach for extractive relative to generative, even the huge Gen AI models. Again, I agree with you. You always have to caveat that because it's like, but who knows what happens in the future?
That's right.
But today, the super large language models, in some ways, their size becomes their own problem because the context space becomes so vast that it becomes
right.
difficult to make sense of what you're trying to accomplish specifically. Hence, I think why RAG appeared, right? RAG really helps you efficiently narrow the context window. Although having been in enterprise search for like 25 years, I look at RAG and I say, oh, we're back to search again, right?
That's it.
So
It's just information retrieval from the 90s. Like we're there,
90s information retrieval, in this case, for the purpose of giving a large language model a better context window as opposed to the human.
That's right.
And ultimately giving the human the answer, right? Which search previously hadn't been able to give answers. It's been able to give information that
Right.
could lead. Yeah. How do you think about, it's funny, I was at a dinner with a bunch of chief data officers, and the dinner conversation was dominated by the discussion of agent-based architectures and agentic architecture. And I was like,
Sure.
wow, we barely caught our breath on Gen AI, and we're already onto this.
That's right.
How do you think about, autonomy and reasoning, and in your space, could these objects begin to make decisions in three-dimensional
Mm.
space on their own? If that's a good analogy for what you do. You're obviously far more expert in this than I am.
Yeah, so agents is now the hot topic. I was talking with a colleague who recently left OpenAI to start his own company, and he said it's the summer of agents that actually work. And so who knows, right? But people are excited. Agents to me means something very, very specific, and it might mean different things to different people. To me, when I talk about agents, I'm referring to specifically tool use, which is you type into a language model like you always would, and then they output a structured representation to call a tool. So search is a tool, code interpreting is a tool, Wolfram Alpha is a tool, and there's lots of these. So that's in my mind like the very first step of agents that just started to work. And that's why people are excited because you can actually say, here's a tool to get the weather, and here's a tool to query my database, and here's a tool to call my mom, and it will use those tools really, really well.
Yep.
So from that perspective, Cartwheel, yeah, we use tools all over the place. It's amazing. Like we have a generate tool, we have a remix tool, we have a slow-mo tool, we have a retarget tool, and all of these can, in theory, be orchestrated by some language model if we wanted to. We don't need to right now, but I think we will. Now, where it gets exciting is what sort of other people are talking about with respect to agents, which is, yeah, decision making, totally letting them run on their own and reason about tasks, come up with a plan of which tools to use and so on. Those don't work quite yet. The reasoning specifically, I think, is hard. Language models get really stuck. They often have things that on the surface look really good, but when you try to go and implement them, you don't have the tools or they actually don't make sense. I gave a talk recently to a group of finance folks who care a lot about agents and they care a lot about company building. And the talk was, can you run $1 billion hedge fund with one person?
Yep.
And then an asterisk plus a bunch of agents, right? And the conclusion that I came to was no, not yet, for these reasons. Planning's not good, reasoning's not good, very expensive, too slow. But all of those are kind of engineering problems, kind of science problems. And so I wouldn't be surprised if in the next 18 months it does start to work.
Does human in the loop play a role, certainly in what we do, using it for things like intelligent intake and things of that nature? Human in the loop has been a vital part of this, right? And that's why I think Microsoft was clever and correct in describing it as a co-pilot, right?
Yeah.
very, very specifically decided to do that. It's not a robot, right? It's a co-pilot. I think before that, we were calling it a bionic arm, right? So
Yeah.
it's not a robot. It's an appendage. Do you think agents benefit from this ultimately as well? Because it strikes me that agents need some reinforcement to say, yes, you're doing it right, or no, you're not doing it right, do it this way. And do you think that is going to continue to be a core part of how these become more proficient?
I think so. I think human in the loop is very healthy for the ecosystem. It's healthy for people who want to get more done, and it's healthy for the models to learn more. I mean, that's our fundamental thesis at Cartwheel too. We care so much about empowering artists to do the thing, and we care so little about automating artists to do the thing, right? And so, yes, I believe human in the loop is necessary, certainly for creative tasks, probably also for sensitive tasks, right? Like decision making for insurance, right? I really do believe, but I think it's important that it's not humans in the loop, right? These tools do empower to the point where one person can do significantly more. And so, grappling with that, and there's not actually a great user experience for approval yet. So approving an agent to take some set of actions or giving correction before they take actions, we don't know really how properly to wire that up. And especially like at scale, how do you get one person to supervise 1,000 agents? Again, not really well studied. And so huge room for innovation.
The regulatory angle is tricky too, right? Because as we build these, you really do want the ability at any moment to say, "Hey, dump out to me all the steps you took to reach this decision," right?
Right.
And when you really, we've sort of taken to calling it your decisioning supply chain. Can you go all the way back to the very beginning, the rawest of the inputs that you received, and everything that happened to those inputs to get to a decision? It's very similar to a supply chain, right? Because if you think about a physical supply chain, how do I know where my raw materials came from and who participated in generating those raw materials, and how do I know that they were, of legal age to work and they were working in a safe environment, blah, 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 blah. So like there's a lot of parallels, I think, to this, which is the regulators are going to ultimately, and they always trail the market because it's moving so fast, but they're going to want to be able to say to, like this hedge fund example, right? Like, explain to me exactly how all these decisions were made to reach that point, because we'll surely find that, just like we did with some of the earlier hedge fund meltdowns that used, programmatic trading, that the good news is you can do these things really fast and at scale. The bad news is you can do these things really fast and at scale.
That's exactly right. And reactively and without supervision and so on.
Yeah. So you can make big problems very fast.
Yeah, and it's very fragile. I think that's one thing I want to emphasize. There's an excellent anecdote from one of the very first fabs when they're trying to make computer chips back in Boston. So they had this electronic system where, clean room, and they're trying to lay silicon, and there's all of these challenges. And they found that it was affected by the phase of the moon and the tides, and there's all these things. But specifically, they found that when there was one engineer working, the fab would always break. And they said, like, he's following procedures we don't know. They found out, they traced it back, and he had a copper doorknob on his house.
Yes, I
And
think I remember the story.
the
Yeah.
remnants of the copper on his fingers destroyed the fab, right? Just the atoms. That's the same today with agent workflows.
Good
Who
analogy.
knows where the copper is coming into the system? And so auditing is important, reasoning is important, approval is important, but we're still in the early days of fabbing these agent systems, which is
Really good.
exciting. I mean, I think that's cool.
Yeah. So trying to draw some parallels and differences again, in our world, sort of, we call it staggered loop learning rather than continuous learning. There's a couple angles here, right? So one, in your category, is there a notion of continuous learning or staggered loop learning? And then as the corollary to that, are you pooling data across customers to make your solution better? And then are they okay with that? What are the sort of ethical considerations of that? How do you think about those pieces of the kind of the standard building blocks of most AI systems that you have to decide early on, right?
Right. So, yeah. So there's a number of ways to get feedback in the motion space. So when you type in do a backflip, and you observe the character doing a backflip,
Yep.
we could ask the user for explicit feedback. Is this good? Is this broken? Yes or no, right? That's one obvious feedback. There's informed consent in filling that out and so on. You can get implicit feedback. Did the user download this motion? If so, that's probably good. They used it, right? We're building a set of editing tools in our app where you can generate a motion, but then you can, move the arms and move the character. And those are now deltas that we can use as feedback. The user asked for this, we gave this, it should have been that. And that allows for a really rich learning signal.
Yep.
That's all pooled today. We are still in beta, and so I think that's to be expected. Where I think it gets tricky, and where we're going to be really careful is if user wants to upload reference footage, which we are building out. So you say, here's this beautiful set of animation that I'd like to replicate. Give me something like this. Okay, do they own the rights to that video? Are we allowing them to launder emotion, which we would want to do, right?
Stable diffusion problem. Yeah.
Yeah, that's right. And so in that case, there's lots of problems there. But another one, what if a company has a library of motion that they want to reference? Okay, well, certainly we can't train on that, and we shouldn't expose it to other customers because it's their personal library. So yeah, no shortage of challenging data problems. I think one thing that's great for us, however, is an individual style of motion is not, at least today, a protectable piece of information. I think there's a famous case about the Carlton dance not being sort of a copyrightable motion. I'm not a lawyer, and I don't know, but essentially, if you invent a type of dance or invent a move, if you're an NFL player or something, the current state of the law is that we can generate those moves without your approval of just using that. That may change, and we'll be, of course, agile and responsive to that. But we're in a nice place. Whereas you cannot use the likeness of a person. You can't use an image or their voice or their video without consent. And so, good place to be, but challenging.
If we think about like in the very near future, if not already, you could create a video of me dancing as well as Michael Jackson,
Sure.
right? Because it sounds like what Cartwheel is able to do, or will be able to do, is basically deconstruct him into the geometry of what he did, even like the skeletal geometry, and then reanimate whatever object, or it could be anything.
Yeah, and we couldn't do that.
We could make a zebra.
Right. So you couldn't say, give me Michael Jackson's dance, and we show you actually his likeness doing the dance. It would be his dance on one of our characters.
Yeah, agree. But the geometric representation of his dancing is technically feasible.
That's right.
Yeah.
We do it actually. So we can do the moonwalk. We have the YMCA. We have lots of these like fun dance moves that you can synthesize on our platform.
Yeah. I mean, it seems interesting. I'm always drawn to these, maybe a sort of catastrophically so, the sort of what ifs of technologies like this. But you imagine even in the sports world, using it for sort of in football, running theoretical plays, right, in full animation to show the team,
That's right. Training
in a team meeting, in a training meeting. I could imagine in insurance, workers' comp, recreating accidents, or looking at the geometry of individuals on a manufacturing line and then looking for either areas of danger or areas of improvement, risk areas. Oh, those motions are going to lead to back injuries, right? That kind of thing. So
that's right.
Yeah, it's cool. Very, very cool what you're working on developing there.
We're excited because it is so horizontal. Like we're targeting entertainment today, but yes, everything that moves, and there's lots of things that move, we would love to be able to ambulate.
Yep. Well, great. This has been a fascinating conversation. I hope you enjoyed it too. I think there's always a lot of interesting parallels to how this is developing, but also significant differences by category and by use cases. But you're certainly working on a really interesting problem. I think of it as one of those inevitable problems that will get solved, right? And so good luck with that. I think it's really intriguing. It sounds like you guys are off to a good start with it.
Thank you. I appreciate that.
Good. Well, Andrew Carr joined us here on Unstructured Unlocked. Thanks everybody for listening, and we'll talk to you again soon.